Bench testing a 1961, 1962, 1963 Cadillac headlight switch, non-fog light option, serial number HS08042025, offered by TT Parts Rebuilding. Run-up test. Test number 1, tail and parking light operation. Test number 2, tail and headlight operation. Test number 3, dome courtesy light operation. Test number 4, dash lights set low to high. Test number 5, circuit breaker test. And test number 6, switch terminals insulated from ground. We're using a fully charged battery during the run-up test. And during the run-up test, we're going to boost the battery. Under boost, we're showing 13.81 volts. Also during the run-up test, we're going to monitor the rheostat in Fahrenheit degrees using a digital probe connected to the rheostat outer edge of the rheostat. Test number 1, tail and parking light operation. First position, have our tail, and from parking light, I'm going to set the dash lights to low and off. Again, test number 1, first position, tail and parking light operation. First position, tail, parking, dash lights set to low and off. Test number 3, dome courtesy light operation. Using the pull rod, rotating it, you can ground the tab of the switch body, have an indication of dome light. Features also available in first position. You rotate the pull rod, ground the switch stab, and we have a dome light indication. Second position, we have that feature available also in headlight position. Rotate pull rod, ground the tab, indication of dome courtesy light, and off. Test number 4, dash lights set low to high. First position, you rotate the rheostat to low position for the dash lights. That is the maximum low position or dim position. And we see we have a little increase of rheostat temperature. Rotating to mid-range. Dash lights come up a bit. Up to bright. Full bright. Back to mid-range. To dim and off. Second position to dim position for the dash lights. Mid-range. Bright. And full bright. Back to first position and off. Test number 5, circuit breaker test. To help run the headlight switches, had a built-in circuit breaker. It's a bimetallic contact arm that connects the battery to the switch. Demonstrate expansion of the arm due to overheating in the vehicle wiring or a short in the vehicle. I'm going to put it in first position, and we're going to demonstrate an overheating of the circuit. We see that the connection between the battery and the switch is broken. Connection is reestablished. Expansion of the contact arm, disconnecting the battery from the switch, protecting the vehicle wiring and the switch body. Second position, that feature is also available to simulate expansion of the contact arm. We see we have a disconnect between the battery and the switch. Back to first position and off. Test number 6, switch terminals insulated from ground. Using a standard 12-volt test light, we have continuity back to the battery at the switch chassis. I'm going to probe each terminal of the switch body, demonstrate that the terminals are insulated from ground. First terminal we have is the battery feed to the dash lights, no continuity. This is the terminal to the dash lights, no continuity back to the battery. This is our battery feed, no continuity to the battery. This is our headlight feed, no continuity back to the battery. Tail light feed, no continuity back to the battery. And parking light, no continuity back to the battery. The only continuity we have back to the battery is at the switch chassis. This demonstrates that the switch terminals are insulated from ground.